Hello, good day, viewers. Welcome back. In this virtual class, we're going to look at this question before us. Cos raised to the power of 3x dx. We're going to find the integration. For this here, what we need to do is first and foremost, we have to split these functions into two parts by in the form that we will say let this will be integral of cos x times cos square x dx. Okay, because if we multiply cos s times cos square x, it's going to give us this part. But we recall that from identity, the sine square x plus cos square x is equal to 1. So we'll make cos square x subject of the relations, and this becomes cos square s is equal to 1 minus sine square x. So we replace cos square s with this expression. Okay, and if that happens here, we have a integral of cos x into 1 minus sine square x, close the bracket, or the x. So if we applied the appropriate algebra, if we distribute the integral sine cos x, the x 1 minus sine square x, this becomes integral cos x dx minus integral cos x sine square x dx. Okay, it is very easy for us to do this. Integral of cos x, if we integrate cos, is definitely the result will be sine x. Okay, because when you integrate, when you differentiate this, it gives you sine. So when you integrate cos, it's going to give you, differentiate cos, it's going to give you minus sine. So if you integrate cos s, it's going to give, the result will be sine s. But that is not our issue here. We've already obtained this, that this is our sine x minus integral of cos x sine square x dx. Here we will adopt integration by algebra substitution. Okay, now having a function of this form, the first thing you do, you need to compare the powers. Okay, if the powers are the same, you can set one of the function as to represent an alphabet. Okay, but here, since the highest power here is 2, we set we say let's sine x, we say let what sine s is equal to u. Okay, our integral becomes sine x minus integral cos x, because we said sine s is equal to u, this become times u square times the x. Okay, what next is that we will find the derivative of u with respect to x. So here, this implies that we'll look for the u over the x of sine, and this will give us cos x. Here we'll make the x subject of the formula. By so doing, we'll multiply both sides by the x. Okay, here by the x, and this become the u is equal to cos x dx. Next, we divide both sides by cos x. Divide both sides by what? By cos x. Cos x. So that the x here, the x is equal to the u over over cos s. Okay. Now, in place of the x in this expression, what do we need to do? We'll replace it with du dx. So now let's come this way. This becomes sine x minus integral cos x times u squared times du o divided cos x. So that it is easy here that cos s at the numerator and cos s at the denominator thereof. And our integral become sine x minus integral of u square du. Okay? And you know the integral of s raised to n dx is s raised to n plus 1 all over n plus 1. Here n is 2. So this integral become sin x minus u raised to power 3 divided by 3 plus an arbitrary constant. Very important, an arbitrary constant. But you see, you have to recall that you set u or sin s is equal to u. So in place of u, we'll replace it with sin s. So this become sin x minus sine raised to the power of 3x divided by 3 plus an arbitrary constants. So these are, to operates or how to, evaluate this integral below. Okay, so all you help me do, please help me subscribe to my YouTube channel by hitting the notification button. Have a nice time. See you in my next virtual class.